Hello everyone and welcome to the second lecture on this course, that is Remote Sensing Essentials, and we are going to discuss in this one about the historical perspective of development of remote sensing, how it is started. In the previous lecture we have briefly discussed, while discussing remote sensing platforms, we have discussed about using balloons. So as you know that first remote sensing started in history in 1858, that is the first aerial photograph from hot air balloon, and this is how it was. This is of course the drawing, not the photograph, but this is exactly the aerial photography was started. Of course at that time the quality of camera and images were not that good as what we see today, but nonetheless that was a big development has taken place, that too in 1858, using balloons and taking aerial photographs. At that time these photographs were in oblique direction, not vertically downward or nadir viewing direction. So that was those were the limitations if you start exploiting these photographs for some serious applications. And then people thought, and this was also tested, employing in 1903 the pigeon mounted camera, and this technology was patented. And these of course the payloads which were on the pigeon were very, very tiny, as you know that the bird cannot fly the heavy load. So these were also done, and later on then small planes were also used, plane mounted cameras in 1914 and between 45, and the big development of remote sensing has taken place, especially the aerial photography has taken place during the World War II also. And after that of course then in 1947 the first space based photo was taken on March 7th 1947, and this was taken through a automatic K-12 camera using black and white images by the Viking sounded rocket that reached to the height of 227 kilometer, and the image which you see on the right hand side was taken by this rocket. And then of course by these small missions or steps, lot of learning has taken place since then, and this the scene which you see here covers a large part of America, Mexico, Arizona, Nevada, California, and northwest Mexico too. So because the height is was this much by this rocket, and of course at the time it was also oblique in direction. And then in 1961 the Earth's cloudy surface was also captured by Alan Shepard, who was on board of Mercury Redstone 3, or in short it is called MR3 spacecraft, which was May 5th 1961. This is the first US manned space flight was there, and then the first Earthrise seen from the surface of the moon by first Apollo mission and lunar landing mission which has taken place. So these are the developments, but in most of these photographs or images which you see are oblique in direction. The current remote sensing, which is very common one, is the nadir viewing, vertically looking downward. And then once we started getting these images, the ortho rectifications became also very much possible, and lot of applications started developing. So the real remote sensing started in 1972 with the launch of Landsat 1. If you see the literature or some websites, you may find a different name for this satellite, Landsat 1, instead of Landsat 1. ERTS, Earth Resources satellite, was also mentioned in there in the literature, but later on it was renamed, and this satellite was launched on 23rd of July 1972. And since then a lot of satellites by various countries. Of course the Landsat 1 was launched by US, and USGS later on shifted to NASA, and then in I should say, new generations of satellites started with the launch of SPOT in 1986 by French Earth orbiting satellite, which is in short we say SPOT, because Landsat MSS was giving a spatial resolution of about 80 meter, and when we had the SPOT we started getting 10 meter panchromatic, means black and white, and 20 meter spatial resolution in multispectral. So that was a big step forward from 80 meter to 10 meter and 30 meter. But in between there were also Landsat TM sensors, so which provided data in visible or infrared channels for 30 meter. Of course, in thermal channel it was 60 meter. So from 80 meter we reached to the 30 meter to 10 meter and 20 meter. This image or this photograph we have already discussed in the previous lecture, but the purpose here again to bring this one is to see that how many the various satellites by various countries are there, and each of these satellites either a part of series like NOAA. So now the current in that series or probably last in the series is NOAA 19, and so you think that started in 60s and still the series is going on. So there are a lot of satellites here in this picture, which you see there are series of satellites, and I am talking mainly about remote sensing satellite, but the communication satellite like INSAT also having series, even we went up to the INSAT 3D, and in between lot of INSAT satellites were there also. Then Chinese also had Fanyung or FY1 to 3 satellite, that series was also there. Then 2-4 China again is there, and many satellites were employed. Especially I am talking about the polar orbiting, this was also very common, the NVSat satellite from European Space Agency. For microwave, ALOS Pulsar was also very common. And then there are 2 satellites, Aqua and Terra, for MODIS sensors, that is also very popular. So after this Landsat 1 in 1972, this era between 70s to 80s was the era of digital image processing, era of lot of remote sensing satellites, and of course the development has taken place, and we have gone for spectral sensors also, and its development started basically in 1980s, but a lot of progress has been made here in case of hyperspectral remote sensing. In later discussions we will have a separate discussion on hyperspectral remote sensing, but very briefly I will introduce here that hyperspectral remote sensing, that in the same part of electromagnetic spectrum where currently we might be having 4 or 5 bands, but in hyperspectral remote sensing we might be having 200 bands there of 5 nanometer or so. So very tiny or very thin bands, but number of bands are very large. Spatial resolution may not be that high, but it covers or the spectral resolution is very high. That is why they are called hyperspectral sensors. In 90s we have a lot of global remote sensing systems which covers the entire globe, and then of course in 2000 hyperspectral remote sensing became further prudent, development has taken place. If we see the development of remote sensing in India, then of course it started on April 19, 1975 after the launch of Aryabhat, that was the first Indian satellite, and then of course later on Bhaskara 1 and 2 were also remote sensing satellites which has different sensors on board working on different frequencies. And the real remote sensing development in India has taken place with the development of IRS series of satellites, and then of course ResourceSat, Cartosat and many more satellites are there. So IRS system is the largest constellation of remote sensing satellites for civilian use in operation for India, and which is a global. These are global satellites, so they are covering the entire part of the world with the 12 operational satellites. So currently India is having many more satellites in space. Indian remote sensing program completed its 25 years of successful operations on March 17, 2013. So we are have completed more than 30 years in space. If we look the series of Landsat series, how it has evolved, as the Landsat one we have already discussed that it was launched in 1972. It worked up to January 1978. In between, Landsat 2 was launched in 1975. Landsat 3 had a little less life, but as electronics has improved, Landsat 5 had a very long life. It was launched in 1984 and it worked up to January 2013. And of course, a large part of the Earth repetitively it has acquired the data, provided a lot of images. Landsat 6 was almost a kind of, you can say, as failure, and it was only for a few days. Somehow there some snacks were developed and it did not work. And Landsat 7 of course worked for a very long time. Landsat 8 is still in operation, and it was launched in February 2013. So we are somewhere here, and still it is giving good quality images. Very soon we are going to witness the launch of Landsat 9, a new series in the series of Landsat satellites. Landsat satellites have been very popular, and they have covered about 50 years of their operations in space and have provided large number of images. Big data set have been developed, and Google Earth is having archives also of these data sets. Otherwise also there are a lot of servers which can provide data sets or part of the Earth, maybe 10, 20, 30 images of the same part of the Earth, employing different satellite data in a very organized manner. So that Landsat is still very popular remote sensing sensor, and the data is available free of cost. It can be downloaded from net, and anyone can utilize. Sometimes even you don't have to register for any server. If we specifically look the Indian history of remote sensing, especially after IRS 1A, that is more traditional remote sensing way. Then 17th March 1988, that was the start for IRS mission, and then all these missions were completed. First we get IRS 1A, 1B, 1C, 1D, and then IRS P4, P6, P5, and also they renamed as OceanSat, ResourceSat and Cartosat. And then of course the new series in Cartosat came, that is IRS P7 or Cartosat 2, then 2A, then OceanSat series also came, Cartosat another 2B, ResourceSat 2, and RISAT also came in service. This is RISAT is a microwave satellite which was launched in April 2012. Now as you know that remote sensing of moon has also been started by India, and not only moon but also Mars. So very briefly I will cover the moon, because only on the 22nd July the Chandrayaan 2 has also been launched. So Chandrayaan 1 was launched in 2008. That was our first lunar probes, or it orbited lunar for many times and has acquired lot of images. And of course very recently, as mentioned, that on 22nd July only this year, this moon, Chandrayaan moon, the Chandrayaan 2 was launched, and it is having orbiter, it is having lander Vikram, and it is having also rover Pragyan. So it will take few more days for this orbiter to reach to near moon surface, and then hopefully we would be seeing beautiful images of the moon, and also lot of data about rocks and soils and water availability on moon through these rover which is Pragyan. So this finally this rover would be there on the surface of the moon, will move on the moon and will collect lot of data, and because it is also having lot of sensors which will acquire the soil data or rocks data or a spectrum in different part of EM spectrum, and of course that the data which will be collected by this rover will also reach to the earth through the transmissions and then receptions on the earth. So that is going to be a very exciting time after roughly 20 or 25 days when it reaches on the surface of the moon. As you know that there used to be in books also you would find a lot of comparison or discussion between the satellite remote sensing versus aerial photography. Nowadays people, instead of aerial photography, they would like to discuss satellite remote sensing versus your UAV or this drone remote sensing. So let's, if you can put aerial photograph, instead of aerial photograph you can put drones, but let's keep things currently in the perspective, that if we take this speed parameter, then satellite remote sensing, current satellite remote sensing is very high, and it has got a high temporal resolution, and that sometimes the satellites are revisiting after a few hours, which is not possible, might not be possible with aerial photograph, because these missions have to be planned and then aircraft should be flown there. So speed is slow, sometimes needs more time to cover an area. Level of details nowadays we can have even 30-40 centimeter spatial resolution. One example is given here by GeoEye-1, say a private satellite which can provide data up to 50 centimeter, half a meter resolution. So the resolution wise the satellites are also providing. Of course level of details with aerial photographs can be provided much more. Even nowadays the camera and hardware which we are having, we can have up to 2.5. Weather conditions, of course cloud is a big hindrance in case of satellite, especially passive satellites, and the most of the remote sensing which we discuss is passive remote sensing. And of course in aerial photographs weather conditions bad weather conditions can be avoided. If there is a cloud or other thing, then may not be flown. So there is a choice, but in case of satellite, once it is launched, it is there, and whether cloudy conditions or clean, it will acquire the images. Then what type of data, and then less or less as each new data type needs new satellite launching. That means the different sensors, if you want to change or have a new idea or new development, then a new satellite has to carry. But in case of aerial photography, the same aircraft but different sensors can be there. Then the location, that is another advantage with satellite based remote sensing, that cross border images can be taken. Large swath images can also be taken by the satellites, but in case of aerial photographs it is not possible easily to take the photographs of other side of the border. So in that way cross border images cannot be taken without permission, otherwise there are troubles between countries. Post processing, because it is more systematic and the platforms are more stable in case of satellite based remote sensing, so that post processing or processing becomes easier. Single image covers a very large area. In case of aerial photographs sometimes it becomes tough because large number of images covering a small area. So large data handling and difficult handling is there. In case of passive remote sensing and active remote sensing, now I am discussing these two types of remote sensing. The most of the remote sensing images which we see nowadays are all part of passive remote sensing. Active remote sensing mainly the microwave remote sensing. So also we will have this quickly we will have comparison, and that this is non-invasive passive remote sensing, so does not imply any external source of energy. And but in case of active remote sensing, the sensor itself has to have its own source of energy. It has to send the energy or pulses towards the earth, and then back scattered energy is collected by the sensor again, and this is how it covers or acquire the data. But in case of passive, it is either reflected energy or emitted energy which is recorded by the sensor. And this passive remote sensing measures either, as I have just mentioned, the reflected radiation from the sun, or can be operated during night time, especially the thermal infrared, that is emitted energy from the surface. And so day and night operations are possible. Though day and night operations are also possible with the active remote sensing, because the sensor itself is providing the source of energy. Active sensors emits a controlled beam of energy to the surface and measure the amount of energy reflected back to the sensor. And now these passive remote sensing suffers from variable illumination conditions of sun, especially in daytime, and influence of atmospheric conditions. They play a major role in case of passive remote sensing. But in case of active remote sensing, we can have the controls over illumination signals, and of course the day and night operations are possible. Atmosphere does not play a big role as compared to passive remote sensing. If we compare this UAV or discuss about this UAV or drone based remote sensing, which is nowadays is becoming very common, we will see the advantages and other things associated with this technology. That UAV based remote sensing is for large scale mapping, high resolution mapping, real time assessment, and monitoring activities of various applications. So this is how we employ for UAVs, and UAVs can also perform efficient surveys for disaster prone or physically inaccessible areas, a quick damage assessment of landslides, floods, earthquakes for enabling relief or rescue operations. That is another advantage with UAV, and can acquire data of various environments that are dangerous to human life. So UAV in that way is very advantageous, can acquire visual or thermal images. Basically it is a platform. UAV is a platform, or drone is a platform. It depends on what kind of data you are looking, and accordingly you put a payload or a camera or a sensor, and then data is acquired accordingly. Of course these can be programmed using these GNSS or Global Navigation Satellite System receivers with them. So you can plan everything, and these operations can also become automatic or semi-automatic. What are the disadvantages? There are some disadvantages also associated with the UAV, the limitations in the size of the study area, because these do not fly very high. There are limitations or might be different constraint put by the different countries. So the coverage is relatively very small as compared to normal remote sensing. Constraint in processing of large volumes of data. Generally the data maybe in the video form, and then frame by frame it has to be analyzed. So the processing constraints are very big in case of UAV. Requirement of large scale processing and large storage space may be a problem with UAV. In addition to large storage, it requires existing features capturing and extraction techniques need to be improved, whatever currently which we are having, for processing of high dimensional UAV data. And then moral, sometimes instead of in our own territory, you go on some other territories, or you are flying over somebody's house. So in that way it has been mentioned here as immoral. It can be hacked also, that may be a problem. And then limitations of payload, because these cannot be used for very heavy payload. So payload has to be very lightweighted. But as UAVs are improving, hopefully this problem will be solved to some extent. Of course weather constraints are there. If it is cloudy or foggy or hazy, then these problems, or rainy, then UAV may not function very well. And if contact is lost with controls, then UAV may be lost. So this is a big loss, and that sometimes it is very common, especially in forested areas or in mountain regions, where the the controller cannot see the UAV and loses the control, sometimes also loses the UAV. So this brings to the end of this discussion about remote sensing essentials, and thank you very much.